In this video, we'll look at ways to measure the spread of a distribution. Take a look at these two sets of data, set A and set B. How might we describe them? Well, they're both symmetric and unimodal, and the mode, median, and mean for both are all 6. So by all the measures we've talked about so far, these two data sets are the same. But clearly the numbers in set B are more spread out than the ones in set A. That's where measures of spread come in handy. They give us a way to describe what we see numerically. The simplest measure of spread is the range, which is just the distance between the smallest and largest values of a dataset. For example, in set A, the largest number is 7 and the smallest is 5. So the distance between them is 7 minus 5. The range is 2. On the other hand, set B has a range of 9 minus 3, which is 6. Another way to measure spread is to look at the quartiles, which can roughly be described as the values 1/4 of the way and 3/4 of the way through your data. There are a few different ways to calculate the quartiles, and sometimes those ways will give different results. So it's important to know that different people may have different conventions for how to do this. But here's how you might do it by hand, just to get an idea of what's going on. To begin with, we know that the median is 6, which is the halfway point of our data. Now, if we look at the left half of the data, we can find its median, which is 5.5. This number is called the first quartile, or sometimes the lower quartile, and it's denoted Q1. On the other hand, if we look at the right half of the data, we can find its median, which is 6.5. That's what we call the third quartile, or sometimes the upper quartile, and it's denoted Q3. So while the median splits our data into two halves, if we also add in the quartiles, we're splitting the data into quarters, hence the name. Using the quartiles, we can calculate what's called the interquartile range, or IQR for short. The interquartile range tells you how big of a range is covered by the middle 50% of the data. In this case, the IQR is 6.5 minus 5.5, which is 1. That means the middle half of our data falls within a range of size 1. On the other hand, set B has an IQR of 3, since its upper quartile, Q3, is 7.5, while its lower quartile, Q1, is 4.5. The minimum and maximum, the median, and the quartiles together form what's called the 5-number summary of the data, which gives a pretty good idea of how the whole data set is distributed. We can use the 5-number summary to draw what's called a box plot. In a box plot, we draw a box that extends from the lower quartile to the upper quartile, and we put a line where the median is. Then we draw 2 lines from the quartiles that reach the minimum and maximum. These lines are sometimes called whiskers, which is why you'll sometimes hear this called a box and whisker plot. Notice how the box plot neatly divides the data into quarters, from the minimum to Q1, from Q1 to the median, from the median to Q3, and from Q3 to the maximum. Each of these sections always contains 1/4 of the data, no matter what the box plot looks like. We can even put box plots side by side to see at a glance how two datasets differ. Now we can see much more easily that dataset B is more spread out than dataset A. Let's look at one more way we can use the IQR. Suppose we took dataset A and changed the lowest number to 1 and the highest number to 8. See how 1 seems kind of disconnected from the rest of the data, like it doesn't fit in? That's what we call an outlier, since it lies far outside the main bulk of our data. But what if that 1 was a 3 instead? How far off is too far off? That's where the interquartile range gives us a handy rule of thumb to determine whether something is a likely outlier. What we do is we first calculate the quartiles and the IQR. Then we find Q1 minus 1.5 times the IQR. Notice that the multiplication happens before the subtraction. In this case, that comes out to 4. Then we find Q3 plus 1.5 times the IQR, which comes out to 8. Anything less than the lower number or greater than the higher number is most likely an outlier. 3 falls outside that range, so it's probably an outlier, while 8 is right on the edge, so it still fits in our data. On a box plot, we usually use a dot to show an outlier, and we only include non-outliers within the whiskers. Keep in mind, by the way, that this 1.5 IQR rule of thumb is exactly that, a rule of thumb, not a hard and fast conclusion. You may still have to make a judgment call on what counts as an outlier in the end, but the IQR at least gets you started. As usual, most spreadsheet software like Excel has built-in ways to calculate these measures of spread. Be aware, though, that Excel calculates quartiles a bit differently than what we've done here in this video. So if you use these commands on the datasets we looked at before, you'll get slightly different results. Even so, those numbers will still do the same job, dividing the data into fourths. Just make sure that whatever you use, you're consistent with what everyone else is using.